Ooh. All right, we go. You two, let's start. Listening. Shh. Quiet down, Dodger. Shh. Quiet down. Here we go. Exercise 5F. Moving to 5F. C12. Thank you. All right, here we go. So, like I said, we're moving on to chapter 5, but really, a lot of this you should pick up much easier because you've hopefully been practicing chapter 3 because it's on Monday. So if you practice chapter 3, you'll find you'll be able to do exercise 5F really easily, 5E really easy as well, sketching. The only thing you got to take out in preparation for the next SAT, where it has chapter 5 in there, is the algebra. So if you've been falling behind, the only thing you got to focus on is, can you solve logarithmic equations? Can you solve exponential equations? So all the log rules and all the exponential rules, you get those two down, that's chapter 5. Okay, everything else is just kind of like adding on what you learned in chapter 3, knowing the properties, moving left and right, up and down, does H, okay? All of that's the same things. Application questions, same idea. The thing that you're taking out from chapter 5 is your algebra. Okay, that's what you need to train. Now, I'll do some examples for 5F, but really I'm going to give you that time for today. Again, you choose what you want to do. You can either move on to do chapter 5 or finish up your notes because I'm picking it up at the end of the session. Or 3, start practicing your SAT revision notes revision sheets for Monday. Okay, so that's how you want to use the session. Okay. All right, so I'm going to just go through. Exercise 5F is now about determining equations. I'll have a look at the first example. In order to determine an equation, you have to know the shape. And we know that by looking at that, it's like an exponential graph. And they already told you anyway, so you didn't have to think about that. But from that, you're meant to use your transformation skills from your normal exponential graph. What your asymptotes are, remember I said you have 2 properties for an exponential graph. What were the 2 properties again? Yeah, 2 of them. Ben? Asymptote of y equals 0. What's the other one? Basil? What else do we know about exponential graphs? There's only 2 things. Asymptote and one more. Michael? 1 except at 1 because anything to the power of 0 will always equal 1. Those are the only 2 things you need to know. So, looking at this right now, we do not have 0, 1. It's gone up, okay? And it makes sense as well because the asymptote has gone up. The problem is we don't know how much we're going up by because it doesn't tell you what the asymptote is. Okay, but they've given you 2 coordinates. They've given you 0, 6, 3, 22. Now the only way the reason why they give you 2 things is because it's likely that you have to solve for 2 unknowns. That's why I always said the number of unknowns will tell you the number of pieces of information you need. So in this case here, we're trying to find out A and B, and we've got 2 coordinates to work with. So how are we going to start off solving this? Mazen, what would you do? Fantastic. Start using the coordinates. Okay, so in our case here, we've got an equation that says y will equal to a times e to whatever the x is, plus b. My case is I've got the coordinates 3, when x equals 3, y equals to 22. So that's what you do first. Sub in 22, you got a times e to the power 3, plus b. Voila, you got your first equation. Okay? Wait, let me just delete that part. So this is your first equation. Your second one, if you sub in when x equals 0, y equals to 6. Now let's have a look at that. You got 6 equals to a times e to the power of 0 plus b. But we all know e to the power of 0, which is? 1. But does this whole thing become 1? No, because we have to realize it's a times e to the power of 0. A lot of students write 1 here, and that's wrong. This actually just means a times e to the power of 0, which is 1. Plus b equals 6. So your second equation now is 6 equals to a plus b. Question is, how are we going to solve this? So you got 6 equals to a plus b, and you got 22 equals a e to the power 3 plus b. Two equations, 2 unknowns. What are we going to do? It gets a bit trickier because this is now, you've got x, which was normally the power, you've got e to the power 3. That's why it gets a bit trickier and you can't use elimination method the way you used to. I'll show you a couple of examples later where you have to use a different technique. But let's have a look at these 2. How would I solve this? Mazen?
You subtract both sides by b and sub in.
Fantastic. Now we can do this. We can do elimination method by saying, well, that's 22 equals, this is equation 1. Equation 2, if you have a look at equation 1, that's AE3 plus B. Now this is 6 equals to A plus B. The tricky part here is you're used to seeing, instead of e to the power 3, you're used to seeing 2 or 4. So 4A, take away A, you can figure that out. Right now you got e to the 3A, and then you're going to take away A. So that gets a bit tricky there, but it's the same technique. B take away B is 0. 22 take away 6, which is, what is that? 16? 16, yeah. And now the question is, what's A, e to the power 3 take away A? Yes. Okay. If you didn't know it, just write down what you just said. See, if you don't know what the answer is, you just write A, e to 3, take away A. Write it in the next line. It's okay not to know what it is, okay? It's just, we're just right here. It's okay not to know. You just work with it. So A, e to the 3 minus A, okay? Now from here, this is where you're going to think, well, how am I going to solve this problem? I've got 2 of these A's. Unlike before, usually you only have 1 A, but now you've got 2 of these A's. There's only one technique. What would you do, Ben? Yeah, factorize. As always, just like with the rectangular hyperbolas where we had to rearrange it, same idea with the fractions, factorize it. They both have a common factor of A. Take it out, so you got e to the 3, take away 1, equals 16. And we know that this is actually multiplication, so divide both sides by e to the 3 minus 1, that equals to A. Okay, now, I'm likely to think that this exercise is probably more on your calculator because it's giving you a really ugly example for A. In order to find B, you have to sub this back in and then subtract to find B. So I think it's a calculator work here. Once you get your 2 equations, type in your calculator simultaneous. Okay, so the approach is straightforward, but you see what we are really practicing here is your algebra. Okay, everything that you've learned, chapter 3, chapter 1, knowing the properties, that's all, everything that you've been doing. And that's exactly what you're going to be doing in your SACs and exams. It's the same things over and over. That's why I said there's only 2 pillars. It's only functions and calculus. Now you're just working on your algebra in chapter 5, same thing in chapter 6. Yeah. All right, here we go. So finding A, sub in A if you wanted to, and we get 6 equals to, whoops, 6 equals to 16 over E3 minus 1 plus B. How do I find B? A lot of students look at this and go, oh, I don't know what to do because it's a fraction. There's only one simple technique and you can just leave your answers that. And they never asked you to have B in a particular way. So, what would you do here? How do I find B? Look at David's. What do I do here? How do I find B? Yeah. Just literally see this whole fraction here. That's what we want to remove. Whatever this is, that's a positive 16 over E3 minus 1. That's one term. So if you want to move it across, just minus both sides by the same fraction. And that takes us away. So right now, on the right-hand side, if I subtract both sides, I'm just going to get, whoops, 6 minus 16 over E3 minus 1 equals to B. Done. If you want to be nicer, just collect the fractions together. But really, you've done B, you've done A. You haven't done anything wrong at this point. Okay? Any questions so far? It's pretty good? Yeah. Let's have a look at the next one. Same thing, now it's a logarithmic graph. We're looking at the properties. Again, properties of log, 2 things again. Richie, name me one. Properties of a log graph. So when I give you y equals log e of x, which... Fantastic. We've got an asymptote at x equals 0, and one more property. What's the other one, Trent? Good. Okay, so it's the inverse of what your exponential was. Exponential was 0, 1, that's the y-intercept. When you do the inverse, it's the other way around. It would then be at 1, 0, so you have an x-intercept of 1, 0. Okay? Because we know log e of 1 is equal to 0. So here we go. 1, 0. Those are the 2 properties. Now, if that's your original graph, then looking at this graph here, the asymptote is no longer at 0. It's moved over here, but I don't know what the asymptote is. Okay? But I do know that the 5, which is where the intercept has moved, is 5, 0 and 8, 1. Same drill again. You got 2 unknowns, 2 coordinates. Okay? But those are the minimum. The number of unknowns you have, you need minimum 2 pieces of information to solve. Okay? So here again, same techniques, and that's what 5F is. That's why I'm trying to say that it's the same drill over and over. But what are they practicing here? It's the algebra. See, from the first step to the second step, the main thing that we've been doing is just sub and try to solve. Elimination method, substitution method, it's the same thing. Yeah? So if I were to do this, same thing again, sub in 5 zeros. If I sub in 5 0, I get 0 equals to A log E of 5 plus B. And then my second equation, I get sub in 1, and I got A log E of 8 plus B. Now this is tricky. You got 2 equations. How do I do this? It's all algebra now. Everything's about algebra. That's what I'm trying to say. Chapter 5, you're trying to take out. Trying to learn how to manipulate the equation so you can solve. What do we do here? Very different to your linear. How do I remove? I could try to use substitution. It'll make it a bit trickier, but I'm thinking of something else. What's another way to solve this? Yes, Aaron?
Just brainstorming right under this one. You put log. If you somehow log both sides and cancel out the logs. Like you put if you put it's like E log E, it cancels out log E, but then like the A is there, so it's a bit of an issue.
Yes, the A is the issue. If the A wasn't there, then you're right. You can do exponential 1 exponential log E, then yes, they will cancel out. Problem is the A. Divide. Right. That's the easiest way. From the elimination method, it doesn't have to be add, it doesn't have to be subtract. You can divide both equations as well. And in exponential logs, most of it is multiplication and division. So what you are required to do is to divide them. Okay, divide more times. It's up to you. In this case here, I can say take equation 1 divided by equation 2, okay, A divided by A will remove itself. Yeah, you can do that. So A divided by A will cancel out. So if I do that, I can say equation 1 divided by equation 2, so this is 1, this is 2, 0 divided by 1 comes 0, and remember, you can't do it the other way. You can't say equation 2 divided by equation 1 because 1 divided by 0 is undefined. So we got A divided by A, which becomes 1, and then log E, so log E of 5 plus B over log E of 8 plus B. Now, if you solve that, now you got 0 is equal to log E of 5 plus B divided by log E of 8 plus B. How do we solve this now? What are we going to do? This trend.
You have 2 logs like that. 2 log E, 3.
What do we do? Tina? Yes, you can, yeah. And that's a good point to bring up, because yes, a lot of students will mix between this rule with log rule number 2. Remember, log rule number 2 was if you had log base E of something, take away log base E of something, then it's the same as division. But remember, it's log E of the division, not log E that, log E that. So what do you do here?
Times the side by the denominator.
Yeah, and that's what I've always taught you. I've always taught you that if you have a fraction, you hate fractions, what do you do? Get rid of it.
Stop doing math and do a different subject.
That is also a good tip as well. Okay? So if you don't like it, you can times both sides. It's okay. Okay? It's okay to say, I'm going to multiply both sides here. It's when you divide that you're going to be careful. So when you divide, we know that we can't divide by 0, but you can times by anything you want. So in this case here, I can say times by log E of 8 plus B, and times the left-hand side by log E plus B. It'll be the same thing. Okay, so here, if we do that, you now got 0 times log E of 8 plus B is equal to log E of 5 plus B. Because when you multiply both sides by log E of 8 plus B, they cancel out to be 1. Now, what do you do from here now then? Yeah. See here, you've got the 1 log base E. We can do the inverse, which is what you were talking about before. Now you can. There's no A values. We just got the log E, and we know the inverse of log E is base e on both sides. So I'll do e to the power of 0 and e to the power of log e. So I'll do it in blue so you can see. We'll do e to the power of 0 and e to the power of log e. 8 plus b. We know these cancels out. That's 1. So now we've got 8 plus b is equal to 1. Therefore, b is equal to -7. Cool? Okay, so all I'm really doing there, like, I'm just challenging you in that idea. You don't have to do your elimination method the way you've always been used to with linear. You can do it this way too. You can divide. Just be careful. Don't use the wrong rules here. And yes, it's okay to times both sides by the denominator.
X of 0 equals log h plus b. 0 times. Yeah, that turns into 0. Yeah. 0 equals log.
So that looks like an 8. It was a 5, wasn't it? 5. So this is 5. And that will be 5. And that will be -4.
How do you draw your 5?
Yeah, I was doing it against the screen. I wasn't leaning my wrist on it, okay? Give me a break. Yes, Steph?
Could you also, for example, like with equation 1,
Yep.
just make it 0 is equal to log e of 5 plus b to the power of a, and then therefore 5 plus b to the power of a is equal to 1.
Yep.
B is equal to 1.
You can do it that way too. All right. I'm just looking at this one. All right. Last one. I want you guys to have a go with this one. Sorry? Oh, true. Sorry. I was so into finding B. I forgot about A. So now you know B is -1. -1. So let's go with, I like the first one. B is -4.
Yeah, you're right.
What did I write?
You're saying 1, but you wrote 4. Yeah,
-4, yeah?
yeah, you were saying 1.
Oh, was I saying 1? All right, now let's find A. We found B. Finding A, sub it into either equation, either 1 or 2. I'd probably do 1 just because it has a 0 there. So 0 equals to A log E of 5 minus 4. And that's A log E of 1. And log E of 1 is... Oh, this is weird. Maybe I'll sub into number 2 then.
You just won.
That's weird. Why? I wonder if this one works out then. Log E of 8 minus 4 is 4. Oh, okay. I'm just trying to think why the first one didn't work out. Why didn't the first one work out? So, right, ignore it. We found A and B. Okay, it didn't work for the other. All right, next one. I want you guys to have a go at this one using the same techniques I've shown you. You got your equation with 2 unknowns, A and B, and you've got 2 pieces of information. I want you to find A and B, same style, exponential this time. And remember, with elimination method, it doesn't have to be add, subtract. It can be times and divide. I want you to have a go with this one, and I'll give you the solutions.
I think the reason why we could find it is because we used to do the x plus 4 shift 4 units.
X minus 4 would make it move to the right 4 units. Yep. Oh, when we do log E of 1. Cool. No, I get that, but what I don't understand is why, because you know normally once you find B, it should be, doesn't matter which equation you sub it in, you should be able to solve for A. So I don't think I've normally ever encountered one where you can't find it. Yeah. And I'm just trying to think, why would that be the case? There's only one solution to it. I just figured it out actually. The reason why there's only one solution, because when you're dividing, remember there was only one way to divide. You didn't have 2 ways to divide. So that means when you sub it back in, there's only one way to get a solution and one way not to get a solution. Yeah? So remember when we did it, we had 0 divided by 1, or you had 1 divided by 0. Yeah? So if you go back, and this one, yes, you have two equations, but there was only one way to solve for A in this case. It was top divided by 1, but not 2 divided by 1. So that way, when you sub it back in, there's only one of them that would work, not the other. If that makes sense. Whereas if you had linear would work both ways.
Oh my god.
Give me that. That is annoying, but that makes sense. That makes sense. If there's only one way, then surely there's only one equation that would work. Otherwise, it wouldn't make sense. Oh, wait. Hopefully, at least you got the first two equations. How do we solve for A and B? That's what I'm more interested in. Yeah, divide by A. Elimination method doesn't have to be add or subtract. You can do division, because we know A divided by A will cancel out as 1. So here we go. We can do, doesn't matter which way you do it. In this case, it will work for either way. So I'd do 8 divided by 6, just because larger numbers divided by a smaller number makes it nicer. Yeah. So 2 divided by equation 1, you get 8 on 6 is equal to A divided by A. And when you're dividing E to B divided by E to the B, we know that this is 4 on 3. What's E to the 2B divided by E to the B? EB, index laws, subtract the powers. When you divide, you can subtract the powers. So here we go. That's the same thing as writing E to B, take away B. E to the B equals 4 on 3. What do you do from here? A lot of students stop here. And I'm like, you shouldn't stop here. You've been doing this all the way since chapter 5. Just one skill that you need. What do you do, man? Oh, yeah. Inverse operations of the base. So if it's E or it's 2 or 3, it doesn't matter what the base is. It's log of that base. That's the inverse of log. I mean, inverse of exponential. Yeah? Exponential base B, so log both sides with the same base. That's what I'm going to do. I'm going to say log both sides. Log base E of 4 on 3. And then log base E of E to the B. Those two cancel out. They're inverse operations. Therefore, B is equal to log E 4 and 3. There we go. Good. And now we're going to find A. Who's A? Sub it into either one of these. Now, I would sub it into this one so that I don't have to worry about the 2. Yeah? So I'd sub it into the first one, just because there's a 2 there. Sorry?
You divide it.
I did divide it, but remember this one, it didn't matter whether 8 divided by 6 or 6 divided by 8. They're going to get solutions. Whereas the previous one, 1 divided by 0 or 0 divided by 1 mattered. There's only one way to do it, hence why there's only one way to sub it. Does that make sense? Yeah? So in this case here, sub it into 1, just to make it easier for you. 6 equals A times E to the log E 4 on 3. Again, E to the log E will cancel out because they're inverses. That's why you don't have to worry about the 2. And there we go. So A times 4 over 3 is equal to 6. Divide both sides by 4 and 3, which really becomes, 6 over 6 times 3 on 4. A becomes, what's that? Is it? 3, yes, you're right, 9 on 2. There we go. A and B. Too easy. Okay, so you can see chapter 5 is all your algebra. It's about working with your algebra. That's the third pillar. Yeah, we've got 4 pillars for this chapter, this whole course. Chapter 1, chapter 9, calculus functions. Algebra is your third one. That's 75% of your course. Okay, that's everything you need to know. Last one's probability. And I promise you they'll be easy to pick up. Just got to work on the extreme. Yeah, work it over and over. It's the same skills over and over. You go back and forth the same way. They're all the same things. And that's what you're doing for year 12. All right. I'll leave you there. You got, oh, well, that took longer than I expected. What session are we in? 3. No, actually, no, it's good. We've got like a good 20 minutes. I thought I took up a whole session to do that. There you go. 20 minutes.